find two numbers whose difference is 16 and whose product is a minimum. So we need to find two numbers. We can call those numbers x and y if we want to. And the quantity that we want to minimize is their product. So the product, we can use capital P for product, is x times y. And we want to minimize this, but remember that whatever quantity we want to maximize or minimize, we want it to be just a function of one variable. We can't have two variables here. So we have to find some way to eliminate either x or y. And generally, this comes from whatever the restriction is that we haven't used yet, whatever piece of information in the problem is not used. And in this case, the difference of the numbers is 16. So that means that y minus x is 16, or x minus y is 16. We could really do either one, and we're going to end up with the same two numbers in the end. It's just which is going to be x, which is going to be y. We're not sure. So anyways, we have y minus x equals 16. And if we solve that for y by adding x to both sides, that gives us y equals x plus 16. And we can substitute that in so that we can rewrite that product just in terms of x. So now we can say the product is x times x plus 16. And we can leave it like that, or we can write it as x squared plus 16x. Both of those are equivalent ways of expressing that product in terms of one of the numbers. Now, we want to find the minimum product here. We want to know the numbers that give us that minimum. And so we want to minimize the product. And to do that, we're going to need to find critical numbers. And to do that, we're going to need to differentiate. So if we take the derivative of this, that gives us 2x plus 16. And we want to know when this is either undefined or 0. That will give us critical numbers. It's never undefined, so we need to set it equal to 0 and solve. If we subtract 16 from both sides, that gives us 2x equals negative 16. And if we divide by 2, that gives us x equals negative 8. So we know that that is our critical number. Let's actually make a sign chart for our derivative. Now the only factor here is 2x plus 16. That is going to be positive if x is greater than negative 8, negative otherwise. And so our derivative of the product is going to be negative and then positive. So the product is going to be decreasing and then increasing. That means we have a local minimum here. But that local minimum has to be a global minimum. Because if we pick other values for x, that product is going to be higher in either direction. This is the only local minimum. And the function is larger everywhere else, so this has to be the global minimum. And so this occurs when x equals negative 8. Now we were asked to find two numbers whose difference is 16. One of those numbers is negative 8, and we can plug that in to figure out the other number. We know x is negative 8, so we can plug that into y equals x plus 16. So y equals negative 8 plus 16. Well, that's actually going to be positive 8. And so the two numbers whose difference is 16 and whose product is a minimum are going to be negative 8 and positive 8. And if we were curious about their product, it is negative 64. That is the lowest product we can get if we have two numbers whose difference is 16. So the actual answer here, because we were asked to find the numbers, are negative 8 and positive 8. But that corresponding product, in case we're interested, is negative 64. If you pick any other pair of numbers whose difference is 16, the product is going to be larger than that. So that is our optimal set of numbers.